Welcome back, students. Again, I am here to talk about the geotechnical engineering course. So, we were discussing about the index properties in detail. Now, we will be covering today the particle size analysis. Particle size analysis, by the name, I think you understand what we will be doing here. We will actually be looking into the classification of the soil according to their size only. Okay, the classification in detail we will be covering later on, but here only the particle distribution will be seen in detail. So, what is particle size analysis? You can say particle size analysis is a method of separation of soils into different fractions based on the particle size. Particle size means, there is a clay, there is sand, there is silt, okay, and all. So, each of them have a different particle size. Clay is the smallest one, bigger is the silt, then sand, okay, then we can say gravel, boulders are also there. So, they keep on increasing. So, this classification we are talking about. Okay. It expresses quantitatively the proportion by mass of various sizes of particles present in a soil. Now, it is shown graphically on a particle size distribution curve. Okay. We will be dealing with the curve also later on. Grain size analysis helps in determining the gradation and uniformity of soil. Actually, we also have two parameters, that is Cu and Cc, okay, coefficient of uniformity, coefficient of curvature. So, these two help us to grade gradation and uniformity. Okay. This we will be discussing. First of all, this particle size analysis, you can see here there is a table. If the particle size is greater than 300 mm, okay, then it is a boulder, it is called the boulder. From 300 mm to 80 mm, it is named as cobble, C-O-B-B-L-E-S, cobbles. Okay. Then from 80 it was here. Okay. Now, from 80 to 4.75 mm, okay, this is called gravel. Okay, gravel. Then again, what is sand? Sand as a whole will be from 4.75 mm to 75 micron. This is sand. Further bifurcation is done into the sand of coarse, medium, and fine, which will be from 2 mm to 4.75 mm, from 2 mm to 0.475 mm, from 0.475 mm to 75 micron. Okay. So, this is your further bifurcation of the sand. This 2 means sand plus gravel will give you what? This will give you coarse grained soil. Okay, this will give you the coarse grained soil. Then we come to the fine grained soil. It again has two bifurcations, silt and clay. Now, silt will be from 75 micron to 2 micron, okay, and below that means less than 2 micron, this will be clay. Okay. So, this is the general bifurcation according to the particle size. There are coarse grained and there are fine grained. Inside coarse grained there is gravel and sand, and inside fine grained there is silt and clay. All have their accordingly size. Okay. From 80 mm to less than 2.2 micron, we have classified the particles. Now, we will be dealing with the coarse. For coarse soil, we will be dealing with the particle size analysis. In the about the fine soil, we will be dealing in the next class. So, remember, for coarse soil, we generally have sieve analysis. Okay. For coarse soil, we have only the sieve analysis. Now, this sieve analysis may be again either coarse sieve or maybe fine sieve. Okay. Now, what is coarse sieve? Coarse sieve is mainly adopted for the gravels. Remember, this is for gravels. So, since gravel is how much? From 80 mm to 4.75 mm, just now you saw it. So, the sieves which we will be using will be from 80 mm to 4.75 mm. 20 and 10 are included. Okay. This one is the coarse sieve analysis, always done dry. But in fine sieve analysis, what is fine sieve analysis? This is now done for obviously sand. Okay. Now sand, what is the range? 2 mm to 75. Okay. 2 mm to 75 micron. Okay, this is your sand. So we will have these sieves accordingly. We will be having 2 mm, 1 mm, 600 micron, 425 micron, 212 micron, 150 mm micron, and 75 micron. Okay, 7 number. Here we are only 4 numbers. And further, this can be a dry analysis or wet analysis. What are these dry and wet analysis? We will be talking about it later on. The smallest sieve in the size will be 75. Why? Because we are talking about coarse, and after 75 micron, the soils having the size lesser than 75 micron are falling under the fine. So we will only have up to this sieve. Okay, now let us see coercive analysis. This is nearly the procedure. Okay, take the sample coarse aggregate in pan and place it on the dry oven at temperature 100 to 110 degrees centigrade. After drying, take the sample weight to the nearest grams. Okay. Now we have the soil or the gravel, whatever it may be, and we have weighed it after the oven drying. Now arrange the sieves in descending order and put the arrangement on mechanical sieve shaker. Okay, means what we do now, we will be arranging something, suppose like this. There will be a number of sieves. Okay, what are sieves? I have already told you, like this. And sieve, the minimal size will be, suppose if there is a 4.75 mm will be here. This is a pan. Okay, solid pan, means no perforations will be here. This will be here, and here it will be 80 mm, decreasing. Okay, accordingly. So we will be arranging the sieve in this manner. Okay, then what will take place? We will now carry out the sieving process using a mechanical shaker. Why mechanical? Because it gives a better and accurate result. Okay, so we will use mechanical shaker. And finally, for coarse grain, we remember we actually find out what fineness modulus. Fineness modulus. Okay, here also it may be this fineness modulus. Value of fineness modulus is find out. Okay, so then after proper sieving, record the sample weights retained on each sieve and find out the cumulative weight of retained particles as well as cumulative percentage retained on each sieve. Means what we will do, I will show you an example after this. Finally, add all the cumulative percentage values and divide the result with 100. We get the fineness modulus. Okay, so let us see an example. You will understand the process. This is the example. See, we were actually having initially of 5,000 grams. What is 5,000 grams? Means 5 kg. Okay, so 5 kg of soil was there for us. Now what we did, you can see we arranged the sieves like this from 80 mm. Now it is slowly going up to 0.15 mm. Okay, there are different types of sieves, this and that. Now we put all the soil on the top one, means 80 mm, 80 mm sieve. Okay, suppose okay, we will be putting this, suppose is 80 mm. All the soil will be put onto here, and there are number of others also. Okay, so there are numbers of sieves. All these sieves are here. Now this will be shaken. Okay, mechanical shaker is there. It will shake it. Okay, it will move it here and there like this, and it will shake it. So what happens after the test is performed or completed? What we see, what we found out is the weights retained. What is the weights retained? On 80 mm nothing is retained, means it is empty. Okay, after that in 40 mm 250 grams was retained. Okay, similarly in this 20 mm there was 1750, then 1600 and all. Okay, so different retained was found. Now what we do, we find the cumulative weight retained. Cumulative means 0 will be 0. Now how is this cumulative? 0 plus this means 250 will give you 250, Again, how this 250 plus means this one plus this one means 1750 will give you 2000. Okay, again 2000 means this 2000 plus this will give you means 1600 will give you 3600 and so on. Okay. So, we found out the cumulative weight retained in the grams. Okay, you understood this one. Then percentage retained. How will you get the percentage retained? This is 0, so no problem. 5. How will you give 5%? 250 divided by 5000 into 100 in percent. Did you get it? This was 250, total was 5000 grams. So, this upon this into 100 will give you retained. Again, how this one? 2000 upon 5000 into 100, though you will get this 40 and so on. Okay. So, finally, we got out the table or solved the whole table and found out that the sum was coming out for this cumulative to be 717. We add each of them, this plus this plus this plus this plus. So, we found out 717. Is it okay? So, what we now did, we got 717, just now you saw it. Okay, divided by 100, we will get 7.17. Why did you, in the process also there is written, you can see that this is divided by 100. Finally, we will divide by 100 to get the value of fineness modulus. So, we have done the same. So, fineness modulus comes out to be 7.17. What does this mean? The average size of the particle of the given coarse aggregate sample is between 7th and 8th sieve. Remember, 7th and 8th sieve it is, okay, not 7 and 8. It is not the value 7 and 8, it is 7.17. It is not that. It is telling us that average value or maximum value of the soil which was present in this sample will lie between the 7th and 8th sieve. What was 7th and 8th sieve? Count from below. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 7th and 8th, 10 and 20. So, 10 and 20. Okay. So, maximum particle size in this sample is between this and this. This is the general, you can say, the outcome of this process. Now, maximum size of the aggregate and fineness modular, these are different. For 20 mm generally it is 6 to 6.9, and for 40 it will be 6.9 to 7.5. For 75 it will be 7.5 to 8, and for 150 mm it will be 8.8 to 8.5. Okay. So, this was it. Now, fine sieve analysis. Fine sieve analysis means, this is the fine sieve analysis, does not mean that we are going to fine grain. This is the fine sieve analysis of the coarse grain only. Okay. Means now we will be tackling about the sand. Okay. We will be tackling about the sand. It has two parts, dry and wet. Okay. We have a dry sieving, we have a wet sieving. Now, what does these two mean? Wet sieving is carried out for separating fine grains from coarse grain by washing the soil specimen on 75 micron sieve mesh. Means you will take a sieve of 75 micron, suppose this is a 75 micron sieve. Okay. Put the soil in it and put water in it, or wash this soil. Okay. What will happen? Water will obviously leave, and those particles which are smaller than 75 micron, or we can say those particles which are actually fine grained, will also wash out with this soil or water, sorry, will wash out with the water. Hence, what will be remained here? The coarse grain only, the coarse grain only. This is the wet analysis, okay, wet process. Later on this is dried in an oven and we continue the process. So, this is actually a wet process. When is this carried out? When we have to separate fine from coarse grain. And dry sieve analysis is carried out on the particles coarser than 75 micron. Samples with fines removed are dried and shaken through a set of sieves of descending size. The weight retained in each sieve is measured. The cumulative percentage quantity is finer than the sieve sizes are then determined. The resulting data is presented as distribution curve, grain size along x axis, percentage passing along y axis. Means you have understood. I think this process is same as we have done in the just before in the coarse sieve analysis. Okay. So, just the thing is dry and wet, dry sieving and wet sieving. Dry sieving is done when there is no fine grain mixed with the soil. Okay. Otherwise, we have to do the coarse, then we have to dry out and then perform the same. Okay. Now, fine sieve analysis. Soil passing from 4.75 IS sieve and retained on this contains no fine, those soils can be directly dry sieved. Okay. So, dry sieving procedure, let us see. 500 gram of soil is taken, then what is it done? Conduct sieve analysis using a set of standard sieves as given in the data sheet. Then the sieving may be done either by hand or by mechanical shaker for 10 minutes. Okay. 10 minutes is the time, maximum time for which the shaker is used. Okay. Generally we use the mechanical shaker. Weigh the material retained on each sieve, means again the same process. If you have 80 mm, in this case obviously it is fine, so it will start from how much? 4.75, then something like that and go up to below, and last will be the 75 micron obviously. So, in each pan how much it is returned we have to weigh. Okay. Then percentage retained on each sieve is calculated on the basis of total weight. From these result, percentage passing through each is calculated. Then the grain size curve in semi logarithmic graph is drawn or provided. Again in the wet sieve, what is the difference? Here what happens, the quantity of the fines is more than 5%, you can see, hence a wet sieve analysis is required. So, what is done? First of all lumps are broken, then 500 grams of oven dried soil is taken and soaked in the water. For heavy clays, deflocculation is done using Calgon solution. What is 2% Calgon? 2% is obviously the concentration, it is indicating the concentration, but what is Calgon solution? It is actually we can say it is a sodium hexametaphosphate. This is in short known as Calgon solution. Okay. Sodium hexametaphosphate. Okay. This is actually a deflocculating agent. What does this do is, if you have particles, okay, particles of soil, suppose like this, they are carrying charge, due to which what happens, they are attracted to each other forming flocks. Okay. What does this do? This provides them neutralization, so they do not come to each other, they are discrete now. Okay. Or they do not flock. The sample is stored and left for soaking for 10 minutes. After this is mixed, 10 minutes it is left. The mixed through the material is washed until the water filter becomes clear. What does this mean? The same process which I told you before. There is the, suppose this is 75 micron, soils are kept on it. Now soil is water is passed through it. Okay. Water is passed through it. So, water will drain out. With it, the particle is smaller than 75 micron will also drain out. So, we will check until the water is clear here. Okay. Till that we will be washing it. The soil retained on 75 micron is collected and dried in oven. Now, this much which is retained will be dried in oven. Then the sieve through the sieve shaker for 10 minutes and retained soil on each is collected and weighed. The material would have been retained on the pan equal to the total mass of the soil taken in dry analysis minus the sum of the masses retained on all sieve. Means we are again finally doing the same as we did in the dry sieving. Okay. We will be calculating on each how much it is returned, then how much it is passing and all. Then we will finally form the semi logarithmic graph or particle distribution curve. So, this is the final particle distribution curve or grain size distribution curve, for which we have been performing the experiments. This is the plot, you can see it is a semi log graph. Okay. So, here you can see this is the grain size. Okay. This is the grain size and this is the percentage finer. Okay. So, it will obviously reach 100% in the end. Okay, and so slowly if we start from nearly 0 and slowly increase. Okay, in the curve what are their x axis obviously particle size, y axis the percentage final, already I have shown you. Now there are few terms such as D60, D30, D10. What are these? D60 is actually how the 60% of the soil particles are finer than this size. Okay, means D60 is that size of the sieve, this can be said that size of sieve, okay, that size of the sieve through which 60% of the total sample taken, total sample taken will pass, okay, will pass. This is the final thing actually, means 60% of the suppose you have 1 kg of soil, okay, from that sieve, suppose this is the size, let us say 40 sieve size. If from this sieve if 600 grams of the soil passes, then this is our D60. This is the D60, not this. Okay, this size of the sieve is the D60. D60. Similarly, D30 and D10. Now I think you have understood. So let's move further. What is your Cu and Cc? Coefficient of uniformity, coefficient of gradation. Okay, or is also called as coefficient of curvature. Okay, here you can see this is D60, D30, D10 is shown here. This much is the D60, this much is your D10, D25, everything is shown. Okay, now let us talk about this Cu, Cc. Just you have to understand that these are the parameters which help us to grade the soil. Okay, means how the soil is it a fine grain, it is a coarse grain, how, okay, is it a fine grain soil or is it a coarse grain soil? Just we have to find out this only using these two parameters. Okay, this tells us two things. First of all, what is this soil? Either is it a sand or it is a gravel. Okay, first of all, these two things are told by these two parameters. Is it a fine grain soil or a coarse grain soil, well graded soil or poorly graded soil? Okay, these some few parameters can be clarified using these two, Cu and Cc. Just look into the formula. Cu is D60 by D10 and Cc is D30 square upon D60 into D10. Okay, so we have two formulas. Okay, just now I explain you what is D60 and what is D10, what is D30, everything. So I think now you have understood how to calculate these two. Just look into the values. Cc, coefficient of curvature, if it is between 1 and 3, okay, and if Cu is greater than 4, then it will be gravel. Actually, you can write it as, actually talking the, I'm sorry, let me write here only. Cu is, if Cu, please copy it, it is important part. If Cu is greater than or equal to 4, this means it is a gravel. Okay. If Cu is greater than or equal to 6, it means it is sand, gravel and sand. Okay, this is the first part. Cu means coefficient of uniformity. The coefficient of uniformity actually comes into handy to all bifurcate or to identify whether the soil is gravel or sand. Then we come to Cc or coefficient of curvature. If Cc or coefficient of curvature lies between this lies between 1 to 3 included, then this will be well graded soil. Well graded soil. Else if it is not, means if Cc is not the element of 1 and 3, this will be obviously poorly graded. Okay, poorly graded. So, if we have the two things, suppose this and this, okay, and this and this, means if we have Cc is in between this and Cu is in between this, then total what we get? Well graded gravel. Again, if we have this is in between 1 and 3 and this is in greater than 6, this means well graded sand. Okay, this and this. Okay, I think you have understood. This also comes handy a number of times to find out what is the soil and how graded or how poorly graded it is. Here it will be graded A. Okay. So, this was it. You can answer to some of the questions listed here. Next time we will be talking about the fine grained soil classification. Okay. This was for the coarse grain only. Now, for next time we will be conducting the different experiments and consulting about how the fine grains can be classified. Okay. Thank you.